Ayun. So, good evening, fellow ECEs. So, tonight, I will discuss about the cascaded amplifiers. So, in here, I will not discuss anymore the uh, what do you call this one? The two-port network system. But I will discuss about this one, yung mga sinasolve natin last time. So, the RC coupled BJT amplifiers. So, when you say RC, so it is a resistor capacitor coupled BJT amplifiers. So for this given example, so nasa paint na siya. So for the first question, letter A, so calculate the no load gain. So ang kukunin daw natin for letter A is AV and L and the output VO. So without load muna. Okay? So to start, so diba, we have two stages. Okay? We have the stage 1 here, yung Q1 and then Q2. But since as you observe, these two transistors are identical. We have the same resistors used. We have 15 kilo ohms, 4.7, 4.7, 2.2 for the RC and 2.2 here for the second one. Then TIG 1K. Okay? And then of course the beta is 200. Okay. Now at DC analysis, so all capacitors are open. Okay, so walang effect CVI natin, wala ring effect itong 15 kilo ohms dito. And then dito rin open, so we will consider this 1 kilo ohms as the RE to solve for RE na maliit. Okay, so since Q1 and Q2 are identical, so kung ano yung solve natin for Q1, ganun din yung values ni Q2. So, ang titignan kasi natin dito is since we have two stages. So, of course, for stage 1, we have ZI1 looking at this side. Okay? Then, of course, yung output kasi dito is co-connect doon sa base ni Q2. So, this will be our ZO1, okay? Output impedance. And of course, for the ZI2, so of course, looking at this side naman, so ZI2, and of course, we have looking at this side naman, we have the ZO2. Okay, so as you can see, the ZO1, okay, so the RL1, so referring to our stage 1, Q1, ang RL1 natin is equal to ZI2. Di ba? Kasi yan yung magiging load niya eh, di ba? So kung wala sana tong second stage na to, so we have the no load voltage gain, okay? And then we will also try to solve using two-port network system, okay? Para i-compare natin yung mga values. Okay. As you observe here guys, may mga sagot na, okay? I-verify natin kung rounded ba to or exact na values. So for this one, kung mapapansin ninyo, we have a voltage divider network circuit. Okay? So yung R prime natin is the combination of 15 kilo ohms in parallel with 4.7. So R prime natin, okay, referring to stage 1 tayo. Okay, and then referring also to stage 2. Okay, R prime 2 na lang. Since they are the identical nga, diba? So that is 15 kilo ohms in parallel with 4.7 kilo. So the answer for this one is equal to 15K times 4.7 kilo. 15K plus 4.7 kilo. So we have 3.58 kilo ohms. Okay? And of course, for VB1, so VB1, okay, so of course equal to VB2. So VB2 is equal to 20, yung voltage natin, ay yung biasing voltage natin, times 4.7 kilo divided by 15 kilo plus 4.7 kilo. So it gives us 20 times 4.7 kilo divided by 15 plus 4.7 kilo. So we have 4.77 volts. Okay? So now, to get IB, so to get IB guys, hindi ko na siya i-drawing hindi ko na i-drawing yung AC equivalent circuit niya. So I hope that you are already familiar with, you can already imagine kung ano ba yung AC equivalent circuit nito. Okay? So solving for IB, di ba usually nagki-KVL tayo dito sa baba, di ba? We have negative 4.77 plus yung R prime, 3.58 kilo, that is IB, plus we have 0.7 plus 1K, okay, na RE. So 1 kilo, okay, so yung IB, ay yung IE, in terms of IB, di ba, we have beta plus 1. So 201 times IB equals 0. So using your calculator, so yung IB natin is equal to, IB is equal to, so solve ko lang, 4.77 plus 3.58K plus 0.7 plus 1K times 201 times alpha x equals 0. Okay. So we have 19.89 microamperes, that is IB. So solving for IE, have 201 kasi beta plus 1, di ba? Times 19.89 microamperes. So we have 3.99. So approximately, say we have 4 milliamperes. Okay, so ito kasi yung exact value niya. Kaya in-approximate ko. 3.99789 milliamperes. So in-approximate ko na lang. IE is approximately equal to 4 milliamperes. Okay, so try nga natin ano. Ayun, so IE is 4.01 dito. Siguro exact values ang mga ginamit niya rito, kaya ganito, okay? So as you can see naman, puro mga rounded yung ginamit natin. So definitely may discrepancy talaga, okay? So solving for our RE na maliit. So RE, so RE1, di ba? Since they are identical, equal to RE2. We have 26 millivolts divided by IE. So 26 millivolts divided by yung RE natin ay 4 milliamperes. 4 milliamps. So we have 6.5. 6.5 ohms for RE. So, kung 4.1 ang gamitin natin for IE, so we have 6.34. So, may medyo discrepancy. Okay? So, but don't worry. Kailan yan. What else? What do we need? Okay. So, to solve for, we are now ready to solve for ZI1. So, to solve for ZI1, diba? Since at AC analysis, yung capacitors natin are close na. Okay? So, it means that itong 1 kilo ohm natin is shorted na kasi yung current natin, instead of flowing through 1K, so dito na siya dadaloy sa may 20 microfarad since at AC is they are shorted. Okay? So, yung ZI1 natin is equal to, okay, so as you can see, yung ZI2 natin, ZI2 daw, ZI1 is equal to ZI2. So, ZI2 is equal to R prime in parallel with beta RE. Okay? So, solving for that, so R prime natin is na-solve natin. We have 3.58 kilo in parallel with 200 times beta natin is RE is 6.5. So solving for ZI1 equals ZI2 equals 3.58K times 200, 6.5. 3.58K plus 200 times 6.5. Okay. So 953.69 ohms. Okay. So in kilo ohms, in terms of kilo ohms, this is approximately equal to 0.95 kilo ohms. So let's check kung medyo malapit yung sagot natin. Okay. So for the ZI1, ZI2. Okay, so wala namang binanggit kasi diniretso niya na calculate the no load voltage gain. Okay? I-solve na lang natin. And for the Ji1, Ji2, of course, we have yung Jo1 Jo2 natin, yung Jo2 is equal to 2.2K. 2.2 kilo ohms. Okay? And for Jo1, okay. For the Jo1, so this is also equal to 2.2 Jo1, I should say. Sabarin ko lang to. Okay. So, using two-port network, kailangan nating solve yun. Sige, mamaya na lang. Ituloy-tuloy na lang na muna natin to. Okay, so yung RL, ano natin, so, to solve for AV1, okay, solve for AV1, since common emitter yan, so we have, di ba, yung no load natin is negative RC in parallel with RE, di ba, using no load. Pero in here kasi, yung Jo1 natin, yung Jo1, okay, since shorted to at AC analysis to, so may ano na siya, may load na siya. So yung load natin, di ba, sabi ko kanina, yung yung RL1 natin, okay, is equal to Ji2. So meaning, yung RC natin, so in parallel with RL1, but RL1 is equal to Ji2, di ba? So equal to, so yung RC natin is 2.2 kilo in parallel with, anong Ji2 natin? Ito, di ba? Have 0.95 kilo. Of course, negative. Okay? Ano yung RE natin? We have 6.5 ohms. So, yung AV1, okay? So, i-solve natin. So, 2.2K times 0.95K. 2.2K plus 0.95K. Okay, so we have AV1 natin ay negative 663.549. So, say 0.5. Now, for, ito guys, loaded to for this part lang, sa gitna. Okay? And AV2, since walang load pala nakalagay, so AV2, so maglagay na lang tayo. Okay? So, we have negative RC over RE also. So, I have negative 2.2K divided by 6.5. So, 2.2K divided by 6.5. So, we have 338. Negative 338.46. And then, the question is the no load voltage gain for the system. So, meaning the whole system, hindi yung individual load, okay, ng each transistor. So yung AV no load natin, since when we say no load guys is walang load na connected dito sa main output natin. Okay? Sinabing AV and L for the whole system. So yung AV and L natin for the whole system is the product of these two gains, di ba? Since negative times negative, Okay, positive. So, kahit hindi ko na ilagay. Okay? So, pero, sige, lagyan na lang din natin para for the sake of computation times negative 338.46. So, 663.5 times 338.46. But parang ang laki. Wait, tingnan natin kung check ko nga to. Baka mali doon. 2.2k times 0.95k. 2.2k plus 0.95k. Ayun, so mali ako dito. Okay, mali ako dito. So mali ako dito. Okay. So divided by 6.5 pa dapat to. So we have 102. Negative 102.07. So, of course, papalitan na din natin yan. Sorry. Ngayon ko lang napansin. Taka ko sobrang laki. So, negative 102.07. Okay? Negative 102.07 times 338.46. Okay, so we have approximately equal to 34.55 kilo. Okay? Yan yung AV and L natin. So, let's compare kung medyo malapit nga ba. Okay, so 34. So, 36. Okay. Of course, medyo may discrepancy na kasi ang ginamit niyang RE is 6.34A. Yung computed value natin is 6.5A. Yun ang pinalo natin. Okay? So, continue na lang natin yung solution natin. So, wala namang mali dun guys. Okay? It's just that based on computation, yun yung mga nakukuha natin. Okay? So, for the VO, so, we all know that yung VO natin is the voltage gain, but since no-load yan, times VI. Okay? So, we have the VNL, and then what is the input? So, we have the input. Input natin ay 25 microvolts. Okay? So, AVNL, copyin ko na lang din. 34.55 kilo times 25 microvolts. So, yung VO natin is equal to 34.55 K times 25 microvolts. So, we have VO is 0.86. Okay. Imili na lang natin. So, 863.5 75 millivolts for VO. Tingnan natin kung medyo ano. Okay, the output is 902. So, medyo may kalayuan ng konti doon sa ano natin, computation natin. Okay? So, ayan. Sabi ko kanina is, let's compare these values using yung two-port network analysis. Okay? So, pwede ko naman nang burahin tong side na to. Ayan. Okay. So, yung two-port network design nito guys is ito. We have two stages, right? So, let's say ito siya. Okay. Then, ito. Ayan. So, ang ZI dito, so say this is AV1. AV1 and then AV2. Okay? So, yung ZI natin, ito compute naman. And then, ZO. ZO natin is 2.2. Okay? 2.2. Para silang 2.2. Same lang din dito. Okay. In here is, we have the AVNL. Okay? So, the AVNL here is, anong susundin natin AVNL dito? So, ito pong susundin natin na AVNL. Okay? Kasi without load, di ba? So, negative RC divided by RE which is equal to 338.46. And since they are identical, so kung ano yung values dito, yun yung value dito. Diba? Negative 338.46. Okay? And of course, connected yan. Then this is VO. Okay? Positive, negative. Ayan. At this side, meron tayong input dito na ano, 25 microvolts. So, dito yung ZI1. Then, dito yung ZO1. Of course, dito yung ZI2. And of course, dito yung ZO2. Okay. So, to solve for the loaded gain for this one, di ba? Yung ZI1 dito is equal to 0.95K. Okay? So, ito, the same lang naman dito. Then, of course, ito, the same lang naman kasi they are identical. Okay? So, yung RL1 natin, so, yung RL1 equals ZI2 di ba? So, yung AVL natin, okay? AVL1 is equal to, so, yung load natin na 0.95. So, we have 0.95 divided by K yan over 0.95K plus yung ZO which is 2.2 kilo times yung AVNL na negative 338.46. Okay? So, let's just solve this using two-port network. Let's just see kung applicable siya. 0.95K times negative 338. 0.46. Times 0.95k plus 2.2k. Ayun. So we got negative 102.07. So is it the same? Okay, so they are the same. Okay? And then of course, for the AV2, since no load yan, so kung ano yung voltage, yung gain natin, yung compute dun sa una, so siya din yung gain natin dyan. So yung AV natin, using two-port network, AV NL, so subscript na lang tayo, 2, so equal to, so negative 338.46. Okay? And then, same process. Since pareho naman yung AVL1 natin using two-port network, so the same lang din yung makukuha natin for total gain natin na 34.55, and of course for the VO. Okay? So ito using two-port network. Then for the letter B, calculate the overall gain and the output if, okay, kung may 4.7 naman tayo dito. Okay? So kung may 4.7 tayo, load is applied to the second stage. So let's compare daw yung magiging results doon sa part 1 sa letter A kanina. Okay, 4.7. So if meron tayong 4.7 daw dito, so kung meron tayong nakalagay na load na 4.7 kilo ohms, so walang magbabago sa gain ng stage 1 natin. Ang magbabago is yung second stage natin. So for the second stage, instead na ito, ay magpaparallel tayo ng 4.7. So for the AV L2, since loaded naman na siya, for letter B, so AVL2, diba, equal to, yung RC natin, magparallel tayo ng 4.7. Negative 2.2K in parallel with 4.7K divided by 6.5. Okay? Equal to 2.2K times 4.7K, 2.2K plus 4.7K. Ayan, so we have divided by, kakalimutan ko ito 6.5. Ayan, so we have 230. Negative 230.55. That is for AVL2. And then, the question is overall gain and the output voltage din. So, the overall gain is just the same kung paano ginawa natin dun sa letter A. So, yung total natin, AVT since loaded naman na yan. So, ito. So, yung AV1, siya pa rin ang kukunin natin kasi loaded naman na siya, di ba? Hindi magbabago, sabi ko nga kanina. So, negative 102.07. Negative 102.07 times. Ito lang magbabago yung sa stage 2 natin. So, negative 230.55. So, 102.07 times 230.55. So we have 23.53 kilo. Okay? And for the VO natin is AVT times VI. So 23.53 kilo times 25 microvolts. So 23.53 K times 25 microvolts. So ang VO natin ay 588.25 millivolts. So as we compare our results from letter A, so bumaba, okay? So bumaba yung yung gain natin, di ba? So nasatisfy pa rin natin yung condition that yung loaded gain natin is less than the non-loaded gain. Okay? And then, so using two-port network then, since may connected na 4.7 doon, di ba? 4.7K. So, hindi pa rin magbabago si AV1 natin. So, ang magbabago si AV2 pero loaded siya. So, si AVL2 natin equals, so parang voltage divider lang, di ba? So, 4.7 kilo divided by 4.7. But, what is the ZO? So, yung ZO natin is 2.2, di ba? 2.2 yung ZO natin. 2.2 kilo times yung AVNL, which is equal to negative 338.46. So, yung AVL2 natin is equal to, so let's try to confirm kung pareho lang, times 4.7K. 4.7K plus 2.2K. Okay, so we have negative 230.5045. Okay, so which is approximately equal to this one. Okay, so tama. So next naman is calculate the input impedance of the first stage. So we already calculated that one, di ba? So the input impedance of the first stage, so dito lang, di ba? So yung input impedance is this one. So yung ZI1 natin is 0.95 kilo. For letter C is ZI1 is 0.95 kilo ohms. And for the next output impedance of the second stage, so since hindi niya sinabi kung loaded or non-loaded, hindi naman na-specify. So, base pa rin tayo dun sa figure, okay? So, of course, yung ZO niya, yung second stage is 2.2. 2.2 kilo ohms. Okay, compare nga natin doon. 2.2 and okay. Ito is 0.94. So, medyo malapit dun sa 0.95 na sagot natin. Okay? So, ganun lang po ka simple kung paano mag-solve ng cascaded amplifier. So, we solved this specific example using two methods. Okay, so it's up to you kung ano yung mas gusto nyong method. So, pareho lang naman yung nakukuha natin as compared dito sa mga values. Okay? So, try to solve yung mga examples doon sa binigay kong material. Okay? So, kung common base man yung kasunod, so no problem with that. Alam nyo naman yung configuration ng common base. So, alam nyo kukunin yung ZI niya, di ba? So, may mga materials naman kayo. If you have questions, guys, PM me or mag-message lang kayo sa GC natin. Okay? So, good night, everyone. God bless, fellow ACs.